When we have similar triangles, they are the same shape, but not necessarily the same size. So it's not like similar figures can be congruent. They typically are not. However, corresponding angles are congruent. So this is a big deal. Corresponding angles are congruent. And then corresponding sides are in the same ratio. And so we'll review ratios in a second. But if you want to kind of understand here, we have this triangle with sides PQR, and then this triangle over here is sides ABC. And so we're writing them like if I call this, this looks like the bigger triangle, right? Big and then small. You can see that the triangle the sides ABC are from the big triangle, and then the sides from the small triangle are always in the denominator. It's not that they always has to go big and small, it's that they has to be consistent. So we'll talk about that. Now, the stuff that's down here at the bottom might look scarily familiar and or just scary. So there are ways to prove triangles are similar. We're not writing 2-column proofs for those today or tomorrow. We're going to do like 1 day of it, 2 days of it, 3 days of it maximum in January. But there's 3 different ways instead of 5. But this is where angle comes in. Remember how we couldn't use angles to do congruent triangles, but you can use them for similar triangles. And then when we're looking at these other ones, side angle side and side, it's the fact that the sides are proportional, not that they're congruent. So we're going to get to that, but I want you to realize that that's there because we're going to be looking at pictures that they don't tell you that the triangles are similar, but we have to understand why they actually are. And we're mostly focusing on this idea, which is up here at the top, the angle similarity. Okay, because we'll see parallel lines again, right? And vertical angles again. So all that's coming back. All right. So corresponding sides and proportions is where we're kind of focusing our day. But let's just go ahead and just get those 2 properties down and the way that we word them at this level. So if I want to know if 2 shapes are similar, right? So if shapes are similar, if corresponding angles are congruent, so that's kind of the first thing that's true of all similar figures. And then the second one is the one that makes it different from congruent figures. Okay. So the phrasing that we typically use is we say corresponding sides are proportional. So this is kind of the key word for today, proportional. And if those 2 things are true, then we have similar figures. So maybe up here I should say properties of similar figures. We're going to say similar triangles even. We do sometimes see similar quadrilaterals or other types of shapes, but right now we always kind of start off with triangles. All right, so then just want to review a couple words to make sure we understand the idea of what is a proportion, and I use the word ratio up above. So what am I talking about there? So a ratio, and I can use just 2 things, or I can have what's called an extended ratio and have lots of things. But a ratio can be written with the word 2, like the ratio is 2 to 1, right? Something like that. Or maybe I have like 2 parts orange juice and 1 part Sprite. I'm making a punch of some sort. Does that kind of make sense? It's like a part-to-part ratio. But often they are written with a colon, or you can then take them and put them as a fraction. So a lot of fractional ones are part to whole. But in our situation here, we are doing part to whole. We're doing 1 triangle to the other. So we might turn this and put 2 over 1 as another way to write a ratio. So what is a proportion? A proportion is equal ratios. So then just a very simple example, I might have 5/10, so that's a ratio. And then I might have another ratio that's like 14/28, okay? Now there's a couple ways to prove that those are equal ratios, right? What could we simplify 5/10?
Yes.
Yeah, what's that equal to?
1/2.
1/2, right? So we could say 1/2 equals 14/28 is also, right? 1/2. So that's one way to say that they're equal to each other. But actually another way, and this is how we solve proportions, is to look at those cross products, right? So the word product is the answer when you multiply two numbers together, right? We love to multiply. Multiplying is great because like 10 times 14 is
140.
140. And actually then 28 times 5 is also 140. So when cross products are equal, that means we know the ratios are equal. Okay, so that's a test. That's also actually how we can test which fraction is bigger. Okay, that's actually a skill that my kid was doing this year in fifth grade, which was kind of wild. So he was actually looking at, like, if I take 1/2 and compare it to 1/3, which you guys all know that 1/2 is bigger, right, than 1/3. But if I actually do the cross products, this cross product is 2, this cross product is 3. So he knew that, and this is something you guys learned a long time ago too, that you could use a greater than sign here, because this was the larger cross product. And that works for when comparing any types of fractions. So it all comes back around, doesn't it? All right, turn the page. Beep. So that was a pretty easy page, right, man? Notes-wise? Not bad. Okay, so now we're going to actually start looking at some triangles. And because we're not doing proof until January, I'm going to kind of just talk about it very casually as we do some of these problems, because you're not being told right now that these triangles are similar. But we can certainly look at them. And do you guys see that all the corresponding angles are congruent? Right? So if all, like, that's the angle idea, those triangles are definitely similar. But what I want to talk to you is about the corresponding sides. So there's a couple things we can do here. If we want to, we can name the two triangles. So if I start with the first triangle on the left, looking at those letters, we always like to put them in alphabetical order, right? We would call it triangle ABC. Okay. And so we're going to check, but we're going to say it is right now similar to, and now this is that idea of matching things up. Which angle corresponds to angle A in the other triangle? So A is 77. Which other one is 77? D. Great. What angle it is with B? E, right? And then C is with F. So earlier, we used this strategy before. Do you remember the line them up strategy?
Yeah.
We're going to use it again. Okay. And then this allows us to kind of see our sides and our proportions, our ratios. So for example, let's see if the corresponding sides have equal ratios. So do you guys agree that, we'll go this way first, that AB corresponds with DE? Do you guys agree with that? So I'm going to go ahead and put 22 over 11. Okay, cool. Now I need to find another set of corresponding sides. So I'm going to go ahead and look at the ones between the 40 and the 63. I've got side 12 and I've got side 24. Oh, but I put the 22 on top, right? So I need to put the 24 in the numerator over 12. And then the last set is the side I haven't squiggled yet. The last set is going to be 16 over 8. So you guys tell me. Can we put equal signs between these?
Yeah.
Yeah, they're all equal to 2, right? So because the ratios are equal, and the are ratios of corresponding sides, then yes, the triangles are similar. So we're going to be writing ratios with numbers and variables, but you're also going to see other types of ratios in our multiple choice questions. Okay? So I'm going to scroll down to where we have true proportions for sides. And I am just going to bring down my A, B, C over C, D, E, F here so I can have it a little bit closer to me. All right. And then ABC was the big triangle, wasn't it?
Yes.
Yes. Okay. So I'm just going to put over here big over small. Okay. So for example, we might have a proportion, and proportion is usually just 2 ratios. So I might write down, instead of the 22, I might write down AB over DE. Is that a ratio of sides? Yep. And then next to that, I might do BC over EF. That's a true proportion, ratio of sides. Okay, so that did big triangle over small triangle. Well, guess what? Could they flip those?
Yeah.
Sure they could. So they could do DE over AB is the same thing as EF over BC. So I could have, instead of big over small, I could have small over big. Now, still true, but not as popular, or maybe it doesn't follow the language of corresponding sides are proportional. We could have one fraction for the big triangle and another fraction for the small triangle. So for example, I could do AB over BC is equal to DE over EF. So that is also an okay proportion. And I didn't involve the third side in any of these, but could we just switch out which set of sides we're playing with? I know this is kind of boring and like, who cares and why do I, whatever with this. We're going to have to set up our own proportions, plus they really like these as multiple choice questions. So let's look at some false ones. So a false one would be, and I'm not, there we go. It would be big over small, and then they would put equals small over big, right? Do you guys understand that that's false? So that's bad news. So if we wanted to, like, that would be taking, so as our lettered examples, that would be doing something like AB over DE equals EF over BC. Do you see how I switched, like flipped one of them? Okay, so we have to be really careful about that. The other mistake that can be made is using non-corresponding sides. And they like to throw in that one actually when they do this kind here. So I'm going to try to use this one to help. So say they do the first fraction as AB over BC. But then they do the second fraction as DE over FD, right? FD doesn't match with BC. Do you guys see how that works out? Like, it's not a match. So there's always ways, and so I'm going to try to zoom out so you can see, like with fingers, how you can trace things to see if they work. So this is kind of where it depends kind of like who you are as a learner, like how you like to check these things. Like, so for example, I go A, B, I'm starting here with this one. A, B, D, E, B, C, E, F, right? See how I did the same dance with my fingers for that one? So then like here, even this one, A, B, B, C, D, E, E, F. It's the same dance move. But when I get down into these, where I'm making mistakes, A, B over D, E, E, F over B, C. Do you see how I did this to there and then there to here? That's backwards, right? I can't do that. Same thing with the last one. And I'm using non-matching sides here. I have A, B over B, C. And then it looks like I'm starting off good, right? D, E, F, D. And I go to a side that doesn't belong whatsoever. Super boring. Wasn't that great? Woo! All right. So now the last thing we might have things with which are kind of silly is they might write proportions for angles, which are like, what? Because it really doesn't make sense because corresponding angles are congruent. And so there's never going to be, and we talked about that yesterday, right? The angles never change. All right. So because the angles never change, our angles are always congruent. They start to throw in wacky things to mess with your head to see if you truly understand that scale factor only goes with sides. So, for example, I want to make sure I get a good example to show you. I've lost my paper. Here it is. Yes, sorry. They sometimes do crazy things like this. They'll put, this is a good one, they'll put the measure of angle A over the measure of angle D. Well, that's 77 over 77, right? And 77 over 77 is equal to 1. That's okay. And then they'll do measure of angle, I need to make sure I get the right one, B over the measure of angle E. And that's okay too, because it's 40 divided by 40, which is 1. This is okay. But where the sorry, here we go. So here's the one that I was kind of talking to you about earlier. So multiple choice question. It says triangle ABC has been dilated by a scale factor of 1/2, creating DEF. Which proportion is not true involving the sides and the angles? So let's just double check things. Does it look, and the way they write the names of the triangles should be accurate in the question. So what I mean is I should be able to write ABC over DEF. And if you like to put the lines in there, you can do that, right? So you know who corresponds with who. Ready, Jason? Woo! All right, so let's check the first one. And once again, this is where you can start to use colors if that works for you. So for example, fraction 1, do we like AC over DF?
Yes, we do.
Okay, that's big triangle over small triangle. Do you guys agree?
Mm-hmm.
Okay, now I'm going to go to the next one. CB over FE.
Yep.
So is that one good too? Same kind of dance. So this one is true. All right. I'm going to go ahead and just erase these funny lines I have on here. So that's why I tend to do it with my fingers. So I'm not always coloring all over my pictures. All right, the next one. So we get FE. FE over ED. So this was first, this was second, right? So if this is going to be good, it better be CB, yep, over BA. So is that one okay? Yep, so this one's true. That's not one that I would ever choose to write because I don't like to go from bottom to top. I don't read that way, right? And you're going to have the opportunity to choose. That's why this is important. All right, here we go. Does angle A match to angle D?
Yes, it does.
Yep. And does C match to F?
Yes,
Yep, it does. Okay, so that one has to be true. So this last one better be false. Yeah.
So does that mean you don't have, it doesn't matter like which one's big and which one?
It does not matter
There's
which
no
one's big,
small.
which one's big, which one's small. You can go small, big, big, small, big, small,
Because there's
big, big, small, small.
Because with angles, there's no big and small.
Right. And for angles, yes, it doesn't matter. So, this last one, it has AB over DE. That is okay. But then it has, DF and AC. There's so much wrong with this one, isn't there? Because it went big, small. Then it went small. And then it went not corresponding big. So there's multiple things wrong with this one, which makes it false. Good? So now we're going to use corresponding parts to solve problems. Ready up those calculators. Here we go. Given that triangle ABC is similar to DEF, write and solve a proportion to find the length of DF. So first thing you're going to do is really look at the picture. And it's not that they're different sizes that I care about. Are they oriented the same? Like, doesn't it just look like a translation has occurred? Do you guys agree? Like, the angle on the left goes with the other angle on the left. It's really easy to see correspondence. So we don't necessarily have to do the A, B, C, D, E, F step, because it's pretty easy to see who corresponds with who. Do you agree? Okay, great. So there is more than one correct proportion. Things kids usually do. A lot of kids like to look at this. Does everybody see that there's a fraction bar right there? Yes? You could put 24 over 21. If you're solving, you can make any proportion you want to. Does that make sense? As long as it's valid. And then does everybody see how this is kind of the fraction bar, right? Equals 16 over x. So this is big triangle in one fraction, small triangle in the other. Let's go ahead and solve it. So to solve, you're going to do cross multiplication. So x times 24 is 24x. I have to pick up the calculator. I do 21 times 16. I got 336. Anybody else? Oh, friends, go grab calculators if you don't have them. You need calculators for this unit. Okay? Great. And then I'm going to do what? Divide by 24. Divide by 24. What do we get? Yep, 14. And 14 is the length of DF. So that is one way to do it. I'm just going to show you a second proportion that would work. So once again, just starting off with fraction bar equals fraction bar. If I want to look at corresponding sides, I would see 24 over 16 and then 21 over x. Does everybody see that we still have the same cross products though? Okay, so that's where when we go over homework, one person might not have the same proportion as another person, but both proportions might be correct. Do we got that concept? So going over homework can be a little bit tricky for this unit. Okay, cool. You ready for the next question? Do we need to stretch? Do we need to do the hokey pokey?
You also do the hokey pokey.
Okay, you're the only one enthusiastic. I was trying to get everybody else into this.
Yes.
Moving on.
Yeah.
Okay. So here we go. This happens pretty frequently. They'll give you information in a question, and then they'll ask you to put it on the picture. So let's do that. All right. If Pn is 4, Okay, Luca.
She suspected me.
Okay, no. So, dude,
Looking at me.
okay, Luca, you're the one that's not in your assigned seat.
Oh, she didn't say she needed assistance this.
Luca, once again, who are you in charge of? This is all stuff I have to now edit out of the video. Go back to your seat, because I'm not dealing with it. Did the M get cut off on your paper too?
Yeah.
Sorry, folks. The M is over there. Okay, if MN is 12 and ON is 3, find the length of LN. Now, this picture is scarier than the previous one where we had things that were two separate triangles, right? And they were oriented perfectly with one another. So I'm asking you the question, which angles correspond? Does everybody see the symbols that are on here? That's parallel lines, isn't it? So if we have PO parallel to LM, then we have, well, we already know we have vertical angles, right? That's a set of angles. We have alternate interior angles. And so this is where we need to be careful. If I call that top triangle PON, okay, the bottom triangle, well, N corresponds with N, right? That's, of course, those are vertical angles. They have to be congruent. Which angle is congruent to O? Yeah.
We did the proof.
And then P corresponds with M. So the problem with this question is not only has our triangle been dilated, but you guys see that it's been rotated around point N. So when there's rotation involved, and there's these parallel lines, now we have to be careful as to which sides correspond with which. Because guess what? It's not 4 corresponds with X. It's 4 corresponds with 12. Okay? So this guy corresponds with that guy. Which is why sometimes this is very helpful. ON corresponds with LN. So that's 3 over X. And then if I use this, like, do you see how I go PN? So PN corresponds with MN. And that gives me 4 over 12. Okay, so that's where you have to be careful about your correspondence. Okay, so this one's a pretty easy one to solve, right? We have 4 times X, which is simply just 4X. And what's 3 times 12? Yep, 36. And we divide by 4, divide by 4.
X equals 9.
X equals 9. And then you just want to pause and say, does that make sense that this side would be 9? Yeah, it definitely has to be larger than both 3 and 4, right? When you accidentally switch those, then you would get partial credit because you're still solving a proportion. Your just proportion was not correct to get started with. Okay, turn the page. Beep. Okay, here we go. A few more. Can you guys write the proportion without me leading you? So there will be more than one correct proportion. The way that you're going to check if your proportion is right is if we have the same cross products. Okay? I'm going to do x over 4. Okay, so deep breath. Your proportion is correct as long as you had you had 4 diagonal with x plus 2. Does that make sense? So as long as your 4 is diagonal with your x plus 2, you're correct. As long as your x is diagonal with x plus 6, you're correct. It does not need to be the same exact proportion. You might have it turned sideways or upside down. Okay, great. So there's a lot of x's in this one, isn't there? Okay, so first thing you're going to do is protect in parentheses. Okay, now we're going to cross multiply, but we're not going to finish the cross multiplication in our first step. So this cross product is 4 times, right, x plus 2. And this cross product is x times x plus 6. Okay. And then we're going to get a quadratic. You guys ready to keep going on it?
Yes.
Okay. So the next thing I'm going to do is I'm going to distribute. So once again, you could have your x plus 6 over on this side. It doesn't matter. I'm going to distribute. So here I go. 4x. 4 times 2 is 8. My equal sign is still there. I don't distribute past the equal sign, right? Now I have x times x, everybody, is x squared. And then we get x times 6, which is 6x. Okay. When we see an x squared, we know it's a quadratic, which means we need to set it equal to 0. Okay, so this goes back to algebra 1 now. You ready? We can do this. So I'm going to leave x squared positive. That you always want to leave x squared positive. So that means I'm going to have to subtract 4x and subtract 8. All right. The subtract 4x is going to go under the 6x, right? Subtract 4x. And then I'm just going to put subtract 8 next to it. And this is where I'm at. And I'm going to move the equals 0 over to that side, which is why I'm kind of like not messing with that side here. But you guys agree x squared comes down. What's 6x minus 4x? 2x, positive 2x, right? And then negative 8, or subtract 8, equals 0. All right, now we got a factor. So I need numbers that add to make 2, but multiply to make negative 8. And really, it's multiply to make negative 8 that add to make positive 2. So when you're factoring, right, does everybody remember that it's always x and x up in the front to get the x squared? Right? If I want the multiplication to be negative, that means one has to be positive, one has to be negative. So 1 plus sign, 1 minus sign, right? Remember that part? Okay, now, 8 is a number that's pretty easy to factor. It's 1 and 8 and 2 and 4. But 1 and 8 is like 7 apart or total of 9. So that's not the ones we want, right? We want 4 and 2. But we want positive 2 in the end. So if I put the 2 here and the 4 here, that doesn't work, does it? Right? So I'm going to switch them. Do you guys remember? Hope I'm not like speaking down to you. I'm just trying to help everybody remember. So positive 4, negative 2. We good so far? Okay, now we separate. X plus 4 equals 0. X minus 2 equals 0. And these ones are easy to solve because it's just x. So we have an answer here of x equals 2. And we have an answer here of x equals negative 4. Are both of these are answers to the quadratic, but are both of them valid in our situation? No. So this one is negative, and we can't have negative sign length, so we omit it. And our answer is x equals 2. We do this unit to practice quadratics. I would not necessarily give everyone like 10 quadratics on their quiz. Does that make sense, everybody? We're practicing quadratics. All right, number 4, here we go. This goes back to yesterday. It says in the diagram below, AC is 12. Oh, the triangles are similar. Okay, does everybody see? Oh, wait, ABC, DEC. Ooh. A matches with D. B matches with E. What happened besides dilation? Rotation. Reflection. Can you see so remember there's this can you picture a line of reflection right here?
Yeah.
Yes, so reflection happened. Reflection. Now, why do I bring all this up? So let's look at what it tells us now. If AC is 12 and DC is 7 and DE is 5 and the perimeter of ABC is 30, we'll just put this inside. Perimeter equals 30. What is the perimeter of DEC? So I just want you to pause and think about correspondence first. We only have one side in this triangle. Which side corresponds with it in the other triangle? Is it the 7 or the 5? 7. So the 5 is what we call a distractor. It's not needed. Okay? Do you remember how side length is also multiplied, or side length is multiplied by K, right? The scale factor, and so is perimeter. So perimeter is also proportional. So we could put 12 over 7, that's a set of corresponding sides, and then we can do corresponding perimeters. 30 over our missing perimeter. Okay, so now we just cross multiply. Mm-hmm. What is it? 17.5. 17.5?
Yeah.
17. You might have a previous answer like it's jamming you up in there. Do you have 210 divided by 12?
It says 35 over 2.
It says 35. Oh, 35 over 2. Make it so go. Okay. Friends, our calculators. This is a calculator. And so I know you're a Desmos kid. This is why. Okay, hold on. 1. So when I do, 210 divided by 12, I get this, right? 35 halves. 35 halves is correct, but 35 halves is hard to understand. So you can either go menu 21, which is change it to a decimal, which that's hard for kids to remember. You could also just go back and go 210 divided by 12, put the decimal in the problem. You get a decimal as your answer. The other thing you can do, but it's not always super friendly, and so this is why I choose not to do it, is Control Enter. It works 95% of the time, but if you've done multiple steps in your calculator, sometimes it will take your previous answer and divide it by 12 again, and then you get really wonky things. Do you guys remember this whole decimal business? Okay, cool. All right. Why don't we save the next question for another day? Because I can see that we are fried. So tonight you're practicing this stuff. You have 2 full days. Can I give you the paper and then just talk about the first 4 with you so you don't get mad? Yeah. We hate it when we get mad. Thank you. Okay, man. No man in math class. Right?
Yeah, we don't get angry at
Josie, I'm giving you one extra test. Here's 2. Thank you. And
Of
here's
course.
1
You're welcome.
and 2.
Thank you for giving us this beautiful.
Okay.
picture of mathematics.
So I know it looks like it's intense, it's long, it's not. It's quick as long as you get the big idea. Okay, so what is the big idea? So friends, if you can line up letters, you can do triangles. So let's look at these first 2 triangles. If I call this first triangle O, why don't I have, it's white, OMN. Do you guys see how this first triangle is OMN? Okay, and the O has no marking on it. Which angle matches with O? R. Which angle matches with N? M. P. Which one matches with N? Q. So now, does everybody see how it's doing OM over MN? So guess what you need to put in the top? What goes with OM? RP. And then goes with P, and then PQ. You kind of see how it's the same dance move?
Yeah.
So you're kind of looking, and you can do it with the pictures as well. Like OMMN. PQ. So what do I need? I need this one. But when orientation is kind of changed around, it's a little bit harder. All right, let's look at this one. They tell us that the 2 triangles, or there's 2 lines that are parallel. So what am I doing with my marker? DE, right? Parallel. Angle D corresponds with which angle? A. So if I call the first if I call this triangle ABC, because I like to put ABC down, it makes me happy. The second triangle, A corresponds with D, E corresponds with B, and C corresponds here. So do we understand how correspondence needs to be matched to get the right letters here? Now, RP is the same thing as PR. So if you switch the order of the letters, that doesn't bother me. Does that make sense to everybody? That's the same side. All right. So the first ones are finishing those proportions. The second ones mimic things that you had in your notes today, right? You guys see the one with the angles down at the bottom? When you flip, there's some more crazy multiple choice, like here, this one's got the angles again. The next 2 are finding missing sides, and the last one you need to draw a picture, okay? So, do the best you can. Do I expect perfection day 1? No. But if you don't try, you don't know, do you? Okay. 2 full days? You can do it? I see you on Thursday? Okay, that's all I got. Thanks for playing. Exactly. Everybody's like, all right.